Hi, so welcome back to Processor Architecture. Today we're going to be looking at the components within the CPU. Okay, so the first video gave you that intro, that overall view of the inner workings of the computer. We're going to delve into the components within the CPU today. So as a quick recap, last session we looked at the FDE cycle. Okay, so the CPU fetched data and instructions from RAM and took them back to decode and execute. Today we're going to be looking at what is within that CPU that allows that process to happen. Remember, billions of times a second that fetch, decode, execute cycle is occurring within your computer. Okay, so there is a certain level of abstraction when we're talking about the components within the CPU. If you were studying at A-level or completing a degree in computer science, you would look at the other elements. We obviously are concerned with GCSE, so these are the components that we're going to concern ourselves with. Okay, so to start with, we've got two units. The first one is the control unit, and the second is the arithmetic and logic unit. We've then got a small amount of memory called cache memory. We will look at that in more detail later on, but not particularly in this video today. We have then got 4 registers. Now a register has a specific job. It does one thing, and it's a tiny piece of very fast memory that holds particularly one piece of data. So let's look at exactly what each of those are and their role within the fetch, decode, execute cycle. Now, within the research task that you completed, you should now have notes on all of these components. If you don't, please pause the video over the next 2 slides and make sure that you have got these definitions written down. There's a lot of marks available for definitions, and once you know the definitions, you can then use that knowledge to answer the more complex, bigger mark questions in the exam. These definitions are OCR specific. Please make sure these are the ones you're learning. Okay, so on this page we're going to look at the control unit, arithmetic and logic unit, and cache memory. So the control unit does what it says on the tin. It's in control of the FDE cycle. It's also in control of the flow of data between the CPU and then ROM and RAM and the input and output devices. Again, the arithmetic and logic unit is self-explanatory in its title. It carries out all the arithmetic calculations. It also performs all logic operations. Now, binary shifts are an example of the kind of logic operation it would carry out. We've then got cache memory, which, as we've mentioned before, is very fast memory in the CPU, and it stores regularly used data. So if you load up the same website every day, like your emails, that kind of thing would be held there. It does, however, have a low capacity, and compared to RAM, it's expensive. So it is used for the data that you regularly use. However, you can't hold all the data there, as it would be too expensive in comparison to RAM. So again, moving on to the registers, if you haven't got these definitions anywhere, pause the video now and start to write them down. Please make sure you're learning them. If it was me, I would be getting them written onto some flashcards and getting someone to test me. So we've already said registers are a very small, fast memory location within the CPU. And the 4 that you need to know about: the PC, the MAR, the MDR, and the accumulator, which we'll talk about now. Now, these definitions will seem quite abstract, but as we go through a worked example, they should hopefully make more sense. So the program counter holds the address of the next instruction to be run. Now, that word next should probably be underlined, as it's super important in terms of your definition. We have then got the MAR, and that holds the address where data will be read from or written to RAM. Once the address in RAM has been located using the MAR, the memory data register holds the data or instruction that is fetched from that address. Then if any processing happens, like a calculation, the accumulator will store the results of that processing. I'm going to stop the video here and start a new one. It will follow straight on with a worked example of all of these definitions.